Welcome to today's webinar. The topic today is design of arched masonry structures in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal software. For instance, the webinars, website, newsletters, and so on. I will be the moderator today, and I will also answer your questions during the webinar. My colleague Ulrich Lex will be the presenter. He's responsible for customer support and also for product engineering. And he's the main responsible person for the development of the masonry design add-on, and also for the development of RFEM. Okay, before I hand over to him, I tell you how you can ask questions. I switch off my webcam that you can see the full screen. You can press that button with the question mark, then enter your question here, press send, and then I will receive your question and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, then I hand over to Ulrich. Ulrich, it's your turn.
Thank you very much, Andreas, for your introduction. I want to say hello to all. The topic of today's webinar, as Andreas mentioned, is masonry, in special for arched structures, where I want to show you today how you can create it in RFEM and how it is possible to interpret the results of it. And as a last part, I want to show you how you can create the printout report for it. Masonry have always been an important material for buildings. Also, arched structures are often used. Examples for this can be a volute in a basement or, for example, bridges. In new buildings, these structures are used certainly less, but it is even more important to be able to calculate existing buildings and assess their stability. This is the reason why I prepared two examples today. One structure as a basement with arched surface on the top, and as the second one, a simple example of a bridge, where I want to show how you can estimate the maximal possible load on it, on this structure, with using the stability analysis too. That's all for the beginning. So let us start and switch to RFEM. So I already created a new file in RFEM. The first thing what I want to do is to take a look on the base data. On the main sheet, there's no changes for the default settings. What I want to take a look is on the add-ons. Here I have to check on our masonry add-on to get these things what I need for masonry. So when I have had done this, I can continue with creating new things. At the beginning, I want to create a new material. One material is existing, it's a concrete. I want to use it for the foundation maybe. And the second will be created new. I choose the material type masonry, and here our material model orthotropic masonry. Go to the material database, select our masonry and select one special material, continue with OK. Then my needed data are filled in automatically, and also the parameters what I need for the material model. The first step is done, the material is created. The second step, I want to create a new thickness, for my surface. At the first time, the foundation, maybe 250 millimeters. Apply, create one new thickness with masonry, and in the thickness, continue with OK. If I have done these settings, then I can start to modeling. My building is a very simple building, so I can create it only with lines or directly with surfaces, and I had not to use any data export or DXF file. So I want to start here and have in this direction 5000, here 3000 millimeters. I can also change this from millimeter to meter. It's maybe better for bigger buildings. So I can copy this line and create the line in the front. I can switch the working plane. Just I had to change here the settings in options, units, and here the length from millimeter to millimeter. Okay. And now my space is 1 meter. Okay. I have to 5. So now I can change it. That was I want. Switch my working plane and want to create here one door. So for better modeling, I can now select only the lines in the front. Can create a new arc. Can create here now 2 lines, maybe 2 helper lines. There were created 2 additional nodes. This is not good, so that's why I can use our tool model check and look after identical nodes. You see there were 2 nodes are here, and I can use this option, delete the unused nodes. Okay, and then there is only 1 node available. Here I created this helper lines. I can activate our extension for lines. Okay. Then I can choose this node, go a little bit back. When the yellow cross is coming, then I can extend this line and choose my length. The same in the other side. A little bit back and extend this line. And the next steps, I use this arch again. So after this, I can delete my helper lines. So that's easy modeling. I can cancel this visibility mode. I can select the structure and copy it. I can add here some lines. And my easy building is ready. I can save this structure, and after that I will continue with creating the surfaces. I use here the option select boundary lines because now there are all boundary lines are available. For my foundation, I use the concrete material. Okay. Select here my lines. So one thing I have seen, here are automatically created nodes on lines. Maybe it would be better to have separate lines, so I can use this option connect lines and nodes. After that, the line is divided and the node is displayed as a red one. I continue with select boundary lines, choose my thickness for material, masonry, and can create some masonry surfaces in an easy way. So here I want to create a separate surface, and also for the surface on the top I need not a plane surface, I need here a quadrangle surface, also with the thickness of the masonry material. Okay, and choose the boundary lines, and ready is my easy building. So as a next step, I want to take a look at the supports. With double click on the surface, I choose a rigid support. Okay. So a special thing for masonry material, is to take a look, one view on the axis systems of the surfaces. For interpreting the results, it would be better that the local Z direction is oriented to the same direction. Maybe it would be good if all surfaces, maybe from the wall, are oriented to the inside of the building or to the outside of the building. So I can explain it later better, because we have here results for the minus side or the plus side. And this is connected to this local z-axis. So I want to change it, that all z directions are look to the inside of the building. Here it's okay. Right click and reserve the local axis system. And at the last, what's this? Okay. So for this arched opening, it would be good when the y direction of the surface would be oriented to the arch. This can be done when I go double click on the surface and take a look on this specific axis, input axis, use here axis parallel to lines, can choose my y axis and can define that it should be parallel to this line number 11. It is necessary because the masonry does have two directions, the masonry material, and the y direction is normally the strongest direction. And this is this direction what the load should be acting. Okay, as a next step, we can take a look at the mesh settings. The mesh settings of masonry structures should be around 25 millimeters. Of course, it can be necessary that that this lengths have to be smaller. Then you can use this. We can use this member or this mesh refinements, or it can be necessary that the mesh settings or the mesh is bigger. But normally it should be used about 25 centimeters. Okay. The settings are done, then I can take a look at the mesh. Continue with OK. The mesh will be generated, and the mesh is fine. It's a regular mesh, so I think I would say it is okay for this structure. Here we see, when I separate this surface, we can see that the y direction is oriented according to line number 11, and it's better to see when I activate the axis system of the FE elements. Then we can see This y direction is oriented according the line. Okay. The next step are the loading. Here I want to create a second load case. The first load case is my self-weight. As a second load case, I want to create a surface load with 10 kilonewton per square meters acting as projected on an area. Okay. The load combinations are created automatically. Here I want to modify the static analysis settings. For masonry, it's normally to use even geometric linear calculation or large deformations. And it's important to set some load increments so that the whole load is not acting at one load step on the FE element. It's better if you choose here maybe 5 increments. When you want to see the results of each increment, we have here the option to save the results, but you have to activate it. Okay. And also, do we have to set in the combination wizard that we want to use not second order, that we want to use the large deformation analysis. Okay, after this setting, we can continue with calculation of the structure. So I press calculation. At the calculation diagram, you can see here the method of analysis, large deformation. You can see here the load increments where the solver is computing. You can see this load factor, and in the convergence diagram you see the displacement, the deformation of the system according the load or the load increment. Now we can see that the displacement, the deformation is increasing with the load factor 0.8. Here we have we could now wait until the calculation is finished, but it could be that we have to wait a long time and the calculation will not finish. So I will remember 0.8 and will cancel this calculation at this moment. What can I do to take a look at the deformations at this load factor? I can go to the load combinations, choose the option in the analysis settings and use this modify loading by factor, and insert here maybe 0.7. Can continue with OK and want to calculate the structure again. Then we can take a look at the results after this load factor 0.7. What we see now, when we increase the deformations, maybe what we see now, what is happening? The surfaces on the right and left side are get a big deformation. I think it's clear because this arched surface creates some horizontal load, and the masonry on the side surfaces can maybe not have so big horizontal loads. So maybe when we have to compute the structure in reality, maybe we have to think now if we forgot something, or what we can do that it's working again. There are many possibilities. Maybe we can create a new beam, a concrete beam, like a ring beam on the top of this surface. Maybe you can create some additional concrete column, or what could be do when it is a basement. It could be maybe considered the earth pressure on the outside of these surfaces. And that was what I want to do. Now, with double click, I want to consider some support. I want to create the new supports in local Z direction. Maybe some spring constant. Yes. Okay. And the same on the other side. Okay. I want to change back my factor to 1.0 and calculate the structure again. Now I can see that the deformation is increasing too, but it's getting horizontal after some time. That means that was the right thing what we have done. Here it is the last load step, and we got more load, and the deformation is not increasing anymore. So the structure is computed, and this structure is okay for this load what is now computed. So what can we do now for the result? The first thing is we can take a look at this load increments, but we have done it before. One interesting thing is that deformations. These deformations you can also print to the printout report to see, to create maybe a better view. You can insert some guide object and a clipping plane. You can create a new clipping plane on here maybe. Okay, and oh, just a moment. We have to see the YZ direction. And you can take off the clipped areas, so you can see this deformation. We can create here a new printout report. Some tables are activated by default. Here you can activate or deactivate everything you want. Click on Save and Show, and the printout report will be generated. Here you have the basic informations, materials, thickness, lines, surfaces. You have the information about the load, and you have the information about the static analyze settings. Here you have the information about the calculations, that it was okay. And you can additionally print the needed pictures to the printout report, print graphic to printout report. You can do some settings. Okay, with Save and Show. Then the printout report will be open again, and you have this information in your printout report. So you can easily take the clipping plane off again. What is interesting is always the strains. The basic strains may be in Y direction, and here we can see this plus and minus results. The plus results are always these results. What on this side were the local Z direction is oriented, and the minus side is the opposite. In our case, the results on minus are outside, and the results on plus are inside of the building. When I take a look on this outside results, we can see that here is tension on this edge, and also on the inner side it is tension on the top of the surface. These results are as expected, I would say. Okay, when I take a look now on the outside and inside results on the same place, then you can see if there is a crack through the whole surface. But in our case, on the edge, on the inner side, it's a pressure, and only on the outside is tension. That was all I want to say to this example, and I want to switch to the next one. Here I already created the file so that we do not have to model it. I created here something like a small bridge, I would say. I have my arched structure on the side, some supports. In the middle of the surface, I create a result beam so that I can take a look on the normal forces in the arched structure. As material, I used the same as before for both things. Here, just a moment, I switch off the member. The same material for both things. It's masonry. For the mesh settings, I use now a very small mesh because I want to see some more details on the mesh, and I used it is now created as a section. So I have the thickness of the surface is in y direction. As a load, I created only the same load cases. Here with a load of 25 kilonewton per meters. So when I create this mesh, we can see that we have a lot of FE elements through the thickness of the surface. When I go back to my model before, here we have normally 9 layers through the thickness of the surface. When we take a look on the thickness, then we have 9 layers through the thickness, but we cannot show the results of each layer. We get only results on the outside, on the inside of the surface. If it is necessary to increase this number of layers, we have this option to do it in the thickness. We can select on this option and we can increase this number of layers from 9 to a higher number. But I think the default setting of 9 is okay, only in cases where I have a really thick surface, then you could think about it to increase this option here. So here I have this 25 as loading, my 25 kilonewton per meters. Then I want to know how much load are possible on my structure. That's why I used, in this case, a stability analysis tool. I want to use the stability analysis and the incremental method. I want to increase the loading until the structure falls, and to see the results in each load step, I save the results of increments again. If I compute this, I have done it before because this incremental load increase takes some time. But when I have, as I have computed it and take a look on the result, that then I see that it is possible to increase my load with the factor 2.9. And here I can take a look on my deformations. So when I go a little bit to the theory, I want to switch to my presentation. It is possible to estimate the horizontal force or the maximum horizontal force for such arches by this formula. The horizontal load is the load Q mal the length divided to 8f. F is the height of the arch, and I get with this formula about 186 kilonewton. In my case, I get by the stability analysis about 193 kilonewtons. That shows that the analytical solution is nearly the same as the computer calculation in RFEM. So I think it's a very good result of both ways. I can here show the member force on my result beam and have about 193 kilonewton. So what is interesting again on the surface results? On the surface results is, can we take a look at maybe first at the stresses. When I took on the sigma y stresses, I see a maximum tension of 0.098. When I take now a look on my material, then I can see that the maximum allowable stress is 0.1. So that's why the stresses are not so interesting, because the stresses cannot be higher as it is defined by the material. And if they are higher in the structure, then the calculation will fall and the structure is not able, you are not able to compute the structure. That's why the more interesting things are the strains. And here I can take a look on the epsilon y strains, and we can see that here on the downside are tension strengths, and also here on the upside. For an documentation, can we now say, okay, here one Fe element is about 25 millimeters. Maybe I have here 50 millimeters, 5 centimeters, where I have a tension, where I think cracks are possible, and the rest of the structure is pressure. I can maybe here about 20 millimeters is pressure. And this is a information where we can say, okay, this structure is okay or not. So these things you can, as mentioned before, print in the printout report for documentation and to print the results of it. One option or one thing what I want to show you is, as I said, this stability analysis takes sometimes a longer time to compute. When I take a look on the calculation diagrams, you can see that the load is increasing until the structure fails. Here is a refinement of the last load step. So this takes a little bit of time. If you know about this load factor, you can use again this option in the static analysis settings to modify your factor. Maybe you use a higher load increment. Then you can do some tests, and the calculation does not take so much time, because when I take a look on this calculation diagram, have to create a new one, because I do not have this increment. Because I do not have this refinement at the end, or the solver does not have to compute it in the last detail. It's maybe easier to use such a modification, and only in the last step, when I know the calculation is ready or the system is ready, then I can use this incremental load increasing. Okay, that's all from my side. I want to show you. I want to say thank you for listening, and we'll go back to Andreas.
Thank you, Ulrich, for your presentation. I have got an additional hint for you. Yeah, just use our free online services on our website. For example, the GeoZone tool. Only a few clicks are for free. If you want to use it more often, then you can buy clicks on our website. Where are the cross-section properties, where you can calculate, as the name said, cross-section properties. Then we have a large database of FAQs and knowledge base articles. Then there are the models to download, as examples or templates for your project. Just use the filter settings or the search to find your model. You can also ask Mia, our chatbot, all the time. All is for free. Just use it. The website is dlubal.com. Okay, that's also all from my side. I thank you for your attention. Thanks to Ulrich for your presentation. I wish all a nice rest of the day. I hope we meet each other in a future webinar. Bye bye.